Hi everyone. So till now we talked about NestJS, NestJS TypeORM, NestJS basic fundamentals, core building blocks, NestJS logging, configuration management, NestJS with TypeORM. So now in coming set of videos we are going to go one step up. We are going to just build a simple application with the AI. Let's introduce AI. Why not, right? Just write a prompt and let's see what kind of application we can get, what are the prompt and how we can refactor, review, and then validate the changes done by the AI. Then on top of that, we will start building something. So let's talk about the first video. I am already exploring all these different tools, like how can I write the APIs. So it's not all that the AI will do everything. First of all, it's in today's world, in 2026, we are going to do AI development, the controlled with reviews, right? It's not like AI will just do end to end everything. What we need to do, we need to be there to review it, to control it, refactor it, and manage it. All those things we are going to do. So in the first video, we will try to understand how to do the structure prompting to build an API. Okay, we are going to build an API service. We are going to just give some prompt. It will prompt us. Then we will step by step, we will try to improve, validate, add database, add logging, add authentication, and then finally the product will be ready. So we are going to do all those things step by step with the AI. So what we are going to do, we are going to step 4, generate, critic, improve, optimize, and make it ready for the production. Because if you are writing code with the AI, then all those things should be your skill set. It's not like, okay, the AI is building 99%, AI is building 70%, then 30% you are contributing, you are reviewing, you are approving, and then you are making sure that whatever is being added through the AI is production ready. Okay, so my first prompt will be, we are going to build an API. My first prompt is simple. You are a senior backend developer. Requirement is we are going to build a post API, right? These are the APIs, CRUD operations, DTOs, and validations and all. Let's see what all phases we are going to go through that. So what AI will do is it will structure the code, it will bootstrap the Nest CLI application, add a CRUD operation, and all those things. So we'll try to monitor as much as possible, because how it is setting up the Nest CLI project, TS config, how it is adding the DTOs, folder structure and all, because this is what we are controlling. So I can see package JSON looks fine to me. And it has added readme, Nest CLI, TS config, package JSON. We can also take a look onto individual files. And this is my source folder. It has created root module main.ts, which will bootstrap the application. I think it is going to create a lot of things based on our prompt. So our prompt was CRUD operation, proper folder structure, class validator, class transformer, use TypeScript obviously with the Nest CLI, basic error handling, so it has added error interceptors, clean architecture principle, so it will create a proper folder structure, controller services and DTOs. So here we can see the modules, entities, user entity, right? So till now we haven't assigned any ORM like SQLized TypeORM and all. So it is like a very basic setup we have got. This is a service. So service is like we are talking about the CRUD operation. So find, get, list me all the users, create user, update user, delete user, remove, find all by email. This is the user module, which is doing user controller user service inside it, app module, root module, and then there is a main.ts, which is importing the app module and bootstrapping the application. We have enabled a global filter, exception filter. That is important here. This is the exception filter. So all these things has been handled here. Let's enable all of these. So now what is the other task which it is performing? We can do npm install and npm start dev. So right, what we did is, what the AI did is it's created a simple CRUD operation, created a simple module. So we can just create a simple terminal and try to do npm install. Npm install, and we can check the package JSON. We can just do npm run start and let's see if the application is okay. It doesn't have any ORM layer added yet. It's just a simple CRUD operation. No fancy stuff with the NestJS. It's a plain application we have built. So our basic CRUD operation works, right? I mean, we don't need to worry much about all the things which it has added, because it's a very simple Nest CLI application, and it has nothing. It's just a simple CRUD operation. So security, all these concepts has not been added. It's like a simple user controller, simple get put post delete, no swagger, no security, no middleware, no logging. All these things we will keep adding to improve this example and make it better. So now let's try to improve it here, because if you see, we don't have a validation pipe. We have a validation pipe. We don't have a DTOs, I think. User create DTO. So let's try to see what we can improve here. So what we are going to do, we are going to add a standard error codes for not found, 404 for void request, for 500 for internal server error, all those things. So all these things will be exposed to the controller also. So whenever the APIs, these request methods with the proper status code will be exposed. So we are going to create a standard API response interface in the exception filter, standardized API response object, right? So this is what we are going to return, API response interface, right? Which contains timestamp, path, status code and all, success, true, false, data. If error is there, then error object. Let's accept it. And we have HTTP exception filter. Let's update this a little bit. Here we are going to add all these error codes and all. Let's accept it. Okay. So our application is still up and running. So what we are going to do now, next thing is adding the database. So this is the plain and simple NestJS API. Now we'll extend the existing project to adding the NestJS with the TypeORM. TypeORM is ORM, and we can just use this user entity to have a TypeORM. So for that, what all things we needed? Because we need a Postgres database, so we can have a Docker or Docker Compose. We can have a Docker Compose to create a Postgres container, and then we will connect from this NestJS API to the Postgres container, and we will have a TypeORM, NestJS TypeORM modules all set up. So let's see how the prompt can help us here. Prompt should be able to bootstrap all those things for us. Meanwhile, it is just updating the status code at the controller level. So these are the controllers. At user controller, using decorators, we can show all the different status code the individual controller is going to return. Okay, no content for the delete, created for the creating a user. You can see created status 202, 201, okay, 200, deleted 204. All these status codes. I mean, you can also add a API description, API OK response, API not found response, and all those things to show more information. Now let's trigger our next prompt, which is, this is my existing API which has a user with ID, name, email, created at, updated at. Let's add a TypeORM. How can we do that? So it's a multi-step process. It's going to add a NestJS TypeORM as a dependencies in the package like Postgres PG, NestJS TypeORM and TypeORM. It will update the user entity which we have. Let's see our user entity. It will convert this user entity into TypeORM definition. Right, you can see it. It has updated it. This is the TypeORM way of writing the entity, and these all are good. So I will accept them. This we don't need now. This is a plain and simple user entity representing the user table. And in the TypeORM, what all it has added? It has added a NestJS TypeORM and PG. These are the dependencies it has added in the package.json, and it is creating database config. Let's see where it is creating all those things. App.module. So inside app module, what it is doing? TypeORM module.for root. Okay. We can also do dynamic initialization, because there are two different ways to connect to database: TypeORM.for root and for root async. Let's first accept it, and then we will try to improve this example for using .env. Config service can pass the environment, host, port and all. And we will manage only a single environment variable, which is a database URL. And we will try to do TypeORM module.for root async. Okay. So here I can write some prompt. So I will write something here. Let's use async and use database URL coming from config service. Now it will understand what I wanted to say. I wanted to stress this because this is the change I needed. TypeORM module.for root async. That means I just need database URL in the env and I wanted to use config service for that. So here let's review all the changes. There is a database config and yes, it is doing, I got a database URL. So it is creating the database config object, type is Postgres, which is needed for the TypeORM. URL entity synchronized flagging SSL. So this is the object which I will just pass to the TypeORM module.for root async, which needed a type host port because I am using, okay, yeah. I mean, this is conditional. If I have a database URL coming in the environment variable, then I can just use that, right? I will use that only and I will return this object. If database URL is not there, then use the host port, username, password, and build this whole big config object. It is giving me the config service. I can go to my user module again, sorry, app module, and it is doing TypeORM module.for root async. This is what I needed. Config module is already there. Here, if you see, it is returning with this object and config service. I mean, you can put this there also, like use factory, get the database URL from the config service. Here we are injecting the config service, config module. Same thing can be added there also, but it's better like, okay, I can copy the whole block and put it here in the app module, but it's a good isolation. We have created it. Now TypeORM setup is complete. This is what we used to generally do, right? TypeORM module.for root async, pass the config service, get the database URL, that's it. But we need all the other variables also, right? So this is the for root async is true. We can have a .env file. There is an env example. We can have a .env. And there is already a config module. It is looking for .env file. So we are good. Now we need is how do we deal with the database? There is no Docker Compose or anything. So we will set up our database, but before let's try to update our user entity with the unique key and index. Update user entity with required index and unique key constraints. Because what we need is we need a index on the email is already there. Okay, unique is already true. So that is already good. So these are some of the practice which you need to monitor and improve your code example. Now next thing is we also need to have a Docker setup. So either you can do a Docker setup, Docker Compose setup I need. Docker Compose setup for Postgres. So it will create a Docker Compose container. So we'll just use that thing and we should be good with initializing the database. So all the required index and all has been created here. So it is a good table design, right? So here I don't want to spend much time in setting up all these things. So I have created a Docker Compose file. What it contains are two containers, Postgres, username, password is there. And this is the PG admin, another thing. So here, let's say if DB name is passed, otherwise it will be a Postgres, NestJS users, port will be 5432 if not passed, and then it will start the, it will create a database. This is just a health check. So everything like a full-fledged database container is there. What we will do is these are the commands. In detest mode, we can do docker compose up -d. First of all, do all those things. Let's run all these commands. So what do we have? We just need a Docker containers so that we should be able to connect to the Postgres. And then we will just improve this particular example, demo code for this CRUD operation. If you don't want to go into the Docker Compose thing, you can do the simple this. It will create this database. It will create a Postgres container with all these things created. So let's try to hit this thing. So it has created container. Let's see our Docker container is up and running. Looks like it is. Connect to database. It is connected, right? So we are good. Now you can just start and stop. You can have your env file like this. So let's populate our env with these things. It's already there, right? And database URL. Postgres user username, password, localhost, NestJS users. Okay, we are good. So if database URL is there, it will use it. Otherwise, it will ignore it. So we can just check all these things. If everything is fine, npm run start. I mean, you can have a Docker container through the Docker compose or just run one command. You don't need to worry much about these things. So we need to do npm install because we added some packages like TypeORM, NestJS TypeORM. We need to get it done and then we will start the application. So there is a TypeScript error. Let's try to see what is the problem here. Undefined port, undefined username, type Postgres URL, synchronized boolean should be so. It is not assignable to this. Let me try. I will just say fix build error. I know because we are returning two types here, either this or this. So the type here is little confused. TypeORM module async option. So let's see if it is fixing it. Yes, now this looks fine. We can start the application again. We need to parse int for the port, and now it is should be able to start. Application is started, right? And I'm not sure about the synchronize thing. Synchronize is not equal to production. That means it has synchronized the table. So it has created all these things like index and this all create table for the user. So CRUD operations will work as expected. This is a simple AI to create things with the database for the database and all. Now next thing is I want to add Swagger module for API docs. Let's add it. So these small things I will keep adding, and then logging and monitoring. So for API docs, we need to use a Swagger module, and in the DTOs, you can see it has added API property. And in the app module, we need to register a Swagger module little later, or here like Swagger config and Swagger module.setup. So Swagger module has been added. API docs will give us the Swagger. Now next thing is final, like I wanted to add a little logging and monitoring. So this is where my document, how I wanted to add a request logging using middleware, response time interceptor, structure logging format. And now we can do a little bit more improvement. You can see all the common things are here. So middleware interceptor filters will go here, which is already there. That's good structuring. Config modules, all the modules. Inside module we have a user. So similarly we can have a course. We can have a profile. All these modules will be there. App module will be importing the root module, and then this is how we are initializing the whole application. So I am adding a simple logging module, logging service and logging module, and we will use this logger for the application. I mean, you can use a simple verbose logging also, debug verbose logging, or you can have your own logging module. In the app module, we just import all these things. And this is the middleware has been added. The request logging middleware for all the routes which are there in the application. So for each and every request, this particular middleware will get intercepted and it will just log where is the request coming from. Okay. And I have a logger module. So you can register the logger module at mn.ts, app.useLogger. So everything is plain and simple, right? I mean, I already know all these concepts, so I can also validate them. Config service, I get the app config. I set the logger context, use logger. This is a validation pipe. And there are some global interceptors we can register, like global interceptor, global filter. And app config, if it is app config to know the if it is a production or the development, right? If it is development, then I can just add this Swagger routes. If it is production, then I will not expose the Swagger. This is the port I got, and I will just start the application again. I think everything is accepted. I will kill the application. npm run start. So this is how, I mean, I'm reviewing things also. Here I have a class validator based validation. If we take a look onto the user controller, I need to do npm install because I did a Swagger. And for Swagger, I think I need one more module, Swagger UI Express or something. I mean, it will complain and then we need to install. So these are the UUID validations. And you can see now, this each and every API is showing all the possible error codes. It can throw API response 200, 400, 409, 200, 404. So this is a good documentation for the APIs also, which will be exposed on the Swagger. Now we can see everything up and running. These are just user APIs and everything is documented, right? All the error codes, everything. So this is how you can build a small POC with the AI without writing much. But I'm familiar with the concepts. I'm validating them. You can add now REST test cases, all the other things which you wanted to add with the exception filters, pipes, validations, guards. You can enable the authentication using passport. All those things you can add and you can validate them. Like here I'm creating user, you can just add a login where you can just return a token based authentication. You can use a passport local strategy, passport, JSON web token and all. So you can extend this example to further with the AI. So this is how I was just talking about how we can leverage the use of AI and can build end-to-end application. So from this video, we understood that how we can use AI to build the application. We need to monitor, we need to review, we need to validate everything. Because we need to be familiar with the concepts before doing it. AI won't do everything, right? You have to control, you have to review, you have to monitor it, you have to validate things, and then only you will be able to build something. Okay, so let's continue our AI journey for the backend in the coming videos. So this was the project which we have built with the AI. So this is NestJS core aspects. We were able to build a controller. I mean, we can build anything, right? But I wanted to go a little slow, creating the modules, integration with the TypeORM, adding a TypeORM modules, adding entities. Like here, I have a user entity, user controller, user service, and user module, which has been added in the app module. In the app module, I have some logging middleware. I have a config module, TypeORM module.for root async. And here it is using this TypeORM config, async config. TypeORM async config is inside a config. Right. So, and we also have a Docker setup, which is spinning up the container. So this was my Docker compose file, which was just creating a Postgres container. I mean, you can actually use a simple one single command also, or you can have a whole Docker compose file to spin up the Postgres container or a PG admin container. I will recommend just get started with a simple one Docker container where you are passing username, password, and port and have everything ready. So what did we understood from this overall setup? I mean, we used AI to bootstrap our simple application, which contains the logger, interceptor, filter, custom exception, which is throwing HTTP exception like conflict exception, not found exceptions, and then we are using those exceptions in our controller. There are the response interceptor, then there is a logger module which we are using. We have a request logging middleware. This is the app config. Inside app config, we are passing the logging level, port, node environment and all. Then there is a database config. Database config which we are passing to the TypeORM module.for root async, like the database URL, entity, synchronize, logging, SSL, rejection, unauthorized false. And this is the type object. Now in this module, we have like controller DTOs. So this is how you can arrange the folder structure for your production level application also. Then app module is importing user module. All the root level modules are initialized here. And then main.ts, which is bootstrapping the application. Now, let's use this as a base folder, a base application. And now on top of that, we can think about the more intermediate to advanced stuff on the NestJS on this particular series. So what we are going to do in the one individual videos, we are going to build a lot of things on top of this particular setup, which we have done with the AI, like very basic CRUD operations, but understanding all the concepts and enabling them one by one.